All right, guys, this is actually my round 2 of doing this because for some reason it didn't record the first time, which is very disappointing. We're going to move him up here. Okay, so we are going into 7.3, similar right triangles. So we talked about right triangles prior to your week off of your fall break. And we know that in a right triangle, there's a right angle. Across from the right angle is the hypotenuse, and the two side lengths coming off of the right angle are called the legs. And we're going to work with similar triangles in this section. Remember, similar is just a little squiggle. It does not have the equal sign. Congruent has the equal sign in the squiggle. All right. Sorry, my mic fell. So here I have this picture of this green triangle. Please write it down. Include all the little vertices. And it says the dotted line represents the altitude. So the dotted line is in the center there. Altitude is from the highest point all the way to the lowest point. So just like if you've ever been in an airplane, pre-COVID, the pilot would come on and say, we've reached a certain altitude. That's just measuring where the plane is in the sky all the way down to the Earth's surface. Well, this is very similar to that, except it's not a plane and an Earth's surface. It's just a drawn triangle. So the first thing we're going to do is we're going to take apart this triangle. So drawing that altitude in the middle creates two triangles within the large green triangle. And we're going to not be really creative here. We're just going to call them large triangle, medium triangle, and small triangle. It's the best that I can come up with. So your large triangle is the perimeter, the big large one that's housing the other two. As you can see, my A vertice has one tally, my B has two. So I'm going to redraw it. I'm going to flip it around because right now it looks like it's fallen or something. I'm going to put my right angle, and I'm a creature of habit. I'm going to put one tally up top, two tallies bottom right. And I'm going to label them appropriately. So A had the one tally, B had the two, and C was the right angle. Now inside my triangle, like I said before, the altitude makes two other triangles. This yellow one I'm going to call medium. No rhyme or reason. It physically looks larger than the other one. I don't know if it is. They're not drawn to scale. And I'm going to do the same thing. I'm going to take it out of the large triangle and rewrite it. Same exact tally markings. One at the top, two in the bottom right, right angle in the corner. Now I look to my triangle. This point D is the right angle. A, which is there, is one tally. That means C must be two tallies. And then this last triangle, we're going to call him small, Shorty over here. Same markings because we want them to match up. My right angle, again, is D because they're a linear pair. B has two markings, so that means C now must be one marking. So you can see between my medium and my small, C kind of changed its angle measures. But that's okay. That's usually the case. So now we're going to create a similarity statement, which you guys have made in the past. I'm going to start with my large triangle here. I'm going to work from one tally to right angle to two tallies. So triangle ACB is similar to my medium triangle, one tally, right angle, two tallies, ADC, which is similar to, I did it in the wrong color. It should be in black. Triangle CDB. So all we did was pick apart this right triangle. The large one, we picked it apart to have three triangles all laid out very similarly to each other. I think that's a word. Not sure. That's why I teach math. All right, take a second, write down this second triangle. This right here is a U, as in you are copying this down in your notes. It will make life easier if you have a solid example in your notes. Directions are there. It says create the two triangles formed and write a similarity statement. And then we have a couple directions here. One, first, label your angles. So I already put the tally marks there, so we would all be on the same page. I put S having 1 and R having 2. If they don't give you them, just put them. So that when you're picking apart your triangles, it'll be easier to match up the vertices. It's not a guessing game then. Step 2, split the triangles up. Step 3, write our similarity statement. All right, so I have my large triangle, which is an orange. Right, and creature out of habit. I always put my tally markings in the same spot. T is the right angle, S is the 1 tally, R is the 2 tallies. For argument's sake, let's all label that one medium. Right, 1 tally, 2 tallies. So in this medium triangle right here, my right angle is the U point. As in you are copying this down. My 1 tally is not marked in this triangle, so it must be T. And the 2 tallies is marked. It's R. Then I have my small triangle. S for small, for shorty, or shoddy. I don't really know how to properly say it. You can barely use the word lit in a sentence, let alone the word shorty, shoddy. All right, U is my right angle. My 1 tally is given to me, it's S. So that means this side of T must be 2 tallies. Now we're going to make a similarity statement. What do you think the similarity statement is? Using the pattern ST, triangle STR, is similar to what other 2 triangles? Nicely done. If you said triangle TUR is similar to triangle SUT. All right, we're going to skip to example 2 and then go back up an example, just because these numbers are a little bit smaller to work with rather than the other one. So in this triangle, you can see I've also put a variable and some numbers. It doesn't really make a difference. It just means now when we're splitting apart our triangles into the 3 triangles, we're just labeling a little bit more. Instead of just labeling 3 vertices, we're going to be labeling sides as well. So I put those green marks. I'll erase them. Oh, we erased part of the line. Interesting. There we go. So I'm going to say E is 1 tally and F is 2. So I have my the perimeter of this triangle, 1 tally, 2, creature of habit. E is at the 1 tally mark, F is in the 2, and G is with the right angle. I'm also going to label the sides. E to G, right here, is 3. G to F is 4, and the entire length from E to F is 5. Now I'm going to say this one who looks like it toppled down is the medium. So we all have the same medium in our notes. 1 tally up there, 2 tallies down there. We label away. H is our right angle. 2 tallies is F. That means G must be 1 tally. Now we're going to label the sides. GF is 4. GH is X. I have no idea what H to F is, this spot right here. I don't know. I know the whole thing is 5, but I don't know exactly what that segment is. So I can't label it anything, which is okay. Less work for me. And now my small triangle. My right angle is H. My 1 tally is E. My 2 tallies must be G. And we're going to go and label the sides. EG is 3. HG is X. We don't know what this is right here. Totally fine. All right, we created our triangles. Now, step 2, create a similarity statement. What's your similarity statement look like? Should have been along the lines of e.g. F is similar to triangle GHF, which is similar to triangle EHG. I did my usual 1 tally, right angle, 2 tallies, the whole way across. All right, now we want to set up a proportion and solve. Well, you guys have set up proportions and solved before. Looking at the one triangle where it's all mushed together, it's a little bit harder to set up a proportion. But looking at these 3 separate triangles, it's going to be a little bit easier. So I always look to my large triangle first. It has the most filled in. By that, I mean all 3 sides have a numeric value compared to the medium and small. Medium and small only have one numeric value and the other one is a variable. We want to find x, which appears twice. So I'm going to just focus on my medium just because it's staring at me in the face. I want to find x. X is from G to H. So here's my medium statement. GH is right here. It happens to match up with EG because EG is the first 2 letters in that similarity statement, which is 3. Oh, and I erased it. So remember, making similarity statements, you always want to be consistent throughout your ratio. I'm going to do large over medium. My large side, e.g., is 3. My medium side is x. And I need to equal it to a number over a number or a number and the same variable. You can't have 2 different variables in your proportions. You have to have the same one. Well, since we're working with the red and the blue triangle, the only side in my blue triangle that has a numeric value is from G to F. G to F matches up E to F. E to F is 5. G to F is 4. So big over small, my medium. I cross multiply. I divide. I get x equals 2.4. Beautiful. And this x is the same exact x because it's, the same variable. So it also equals 2.4. Okay, so now we're going to go back up to example 1 because this example is a little bit harder. I already labeled your angles for you and wrote down which one's medium and which one's small. Take a second, write it in your notes. I'm now going to split up my triangles. Large, creature of habit. So now S has a 1 tally. T, R. S to R, the whole thing's 165. R to T is 152, and then ST is 64. My medium. Same markings, right angles M. My 1 tally is what? T. That must be R. What is the only side that I can give a numeric value for? TR, right here, which is 152. And last but not least, my tiny triangle, small. My right angle is what? M. My 1 tally is S. And that leaves T to be my 2 tallies. And what's the only side I can mark? S to T, which is 64. Now I'm putting this variable in here. It's the altitude, M to T, only because it got erased before, and it is white. I mean white. What? Why? I meant to say why, but I said white. It's 8 o'clock. It's close to my bedtime. All right, so let's make our similarity statements. What do you got for our similarity statements from large, medium to small? Should have said something like STR is similar to TMR, which is similar to SMT. One tally to right angle to two tallies throughout all three. Now we want to create a proportion. I want us all to be on the same page. Which triangle has all three sides given about, like they all have a value, a numeric value? The large one, right? So the large one is the one we're going to be equaling our variable to. So let's look at small this time. I want to compare small to large because large has all three sides to work with. Large over small. MT is Y. It matches up with what value in the large triangle? TR, which is 152. So my proportion is going to look like what? 152, large over small, Y. Now my only other value over here in my small triangle is 64. S to T. S to T. Which side length does it match up in my large triangle? S to R. 165. So what's my proportion going to look like? 165 over 64. So what do you get after you cross multiply? And it's okay that it's a large number, or if it's a decimal. All right, so after you did that, you multiply 152 times 64. You should have got, oh Lord, I deleted it on my calculator when I didn't mean to. You should have got 9,728 equals 165x, y, sorry, not x, habit. And then you divide by 164, you get 59, 7 to 8 divided by 165. You get 58.9. So my altitude, or this y variable, is 58.9 in both triangles. All right, I'm going to throw in another variable. I want you to find the value of x. Set up your proportion, compare it to your large triangle, and find the value of x.